So it blocks it. If you can block it, you can see the efficiency of the cancer cell by however you. So that's the second largest cell of the world. Eliquis is nothing but it's a kind of inhibitor factor 10A, which is actually one of the blood clotting proteins. Right? So to prevent the blood clotting, you can use Eliquis. So these are the top three products as per the 2020 pharma business. So if you look at the top inside property, that's not actually a looking for. I'll explain what it is. The market size estimated is around $22 billion by 2031. See, these figures are really very important because whatever work that we do, how the market is there, you have to discuss. Generally, people will be interested to speak with you or to entertain you. Otherwise, and if you do a kind of a very mediocre work, right? Which means anybody can do that work. If not you, somebody else can get the job. But whatever you should have some kind of knowledge with you to be hired by a professional. So we should identify and we should get expertise and we should excel ourselves in that direction. I'll just give a very brief introduction about the dendritic cell-based vaccination and RNA vaccination and transfusion therapy. I'll try to do very briefly. So it's a kind of a classical immunological concept that we have two different antigens, I would say, broadly. The pathogens that are coming from the air, to drinking water, or the food that we eat, they are coming from the environment. Okay. So these antigens, you can say that exogenous antigens. So this exogenous antigen will be taken in a kind of endosomal compartment and it will be processed presented through MLC plus 2 marks. So, if it is a protein molecule, it will be chopped off into small molecules, small peptides, and those peptides can be presented by MLC plus 2 marks. This processed peptide will be recognized by CD4 positive T cells. We have several subsets of T cells. I will talk mainly on CD4 positive T cells and CD8 positive. CD4 positive T cells are meant to recognize the foreign antigens, whereas the CD8 T cells, they are supposed to recognize the endogenous antigens. For example, assume that you have an intracellular parasite or a virus that actually infected the cell and the viral genome got integrated into the cell genome. And then it starts expressing the viral protein inside the cell, along with those cellular proteins. Right? Every protein should have a half-life, means it should die. No protein is permanent. Okay? So we call it as a half-life for everything. Once it got restricted to its half-life, there is a special way of distinguishing between a nascently synthesized protein and a half-life completed protein. There is a way to distinguish like that. So, due to that recognition, cell is smart enough to identify the word of protein and it keeps out into small peptides, and those peptides now presented by MLC class 1 molecule. So previously we talked about exogenous antigens, which is processed and presented by MLC class 2 molecules, recognized by CD4 positive T cells. The endogenous antigens process represented through MSC class 1 molecules and recognized by cytotoxic T cells. Okay. If you look at the HIV positive patients' blood picture, you have increased to 1 ratio with the CD4 versus CD8 positive T cells. It makes sense. You will encounter constantly the foreign antigens because the viral infections are there. Okay? And the cancer protein circulation is also there. Only happens in cancer patients, not in the normal community. So they are not burdened for recognizing the foreign antigen in the other side. You will have double the number of CD4 positive T cells in your body when compared with CD8 positive T cells. Okay? Here I would like to show in this small video how a cytotoxic T cell actually is targeted.
Somehow I'm not able to play it. Yeah, maybe this one. Is it? Okay. No. Somehow I could not able to show you. No. Is there any way that I can play this video? Maybe paper completely. Okay, fine. No voice, no audio. Just try to see the video. Okay. Yeah. Beginning. First you see it, then I will explain. Now I will explain along with the video. So this is the cytotoxic T cell, and this is the MSC class 1 molecule presented peptide. This virus infected cell, which presents the viral peptide, showing in the red color here, right? This is the viral antigen, and this is the T cell receptor. Okay. Upon recognizing the viral peptide, you can see the activation of T cell, and it releases the cytokines. And once it got triggered, the activation, you can see the initiation of perforin granzyme pathway. The perforin molecules actually penetrate through the target cell membrane and make a pore kind of structure. Through this pore, you can see the entry of the granzyme molecule into the cell, which leads to a kind of destruction of the target cell. So this is the activated cytotoxic T cell kills the target cell in a perforin granzyme pathway. Dr. Shivkumar is expert in cell signaling mechanisms and what are the downstream events, how actually cell gets killed in this pathway. He is expert in classical signaling. Okay. Next, I would like to introduce very briefly about a dendritic cell-based vaccination. There is a product approved by US FDA. This is called Provenge. This is actually designed to treat the prostate cancer specific patients. So, actually, what is dendritic cell vaccination and how it works? So you can see the apheresis. Apheresis is nothing but the removal of the blood from the patient. And you can see the various cell types separation. And you can grow these cells by using a cocktail of growth factors. And you can make immature dendritic cells out of these precursor cells. And then you feed these dendritic cells with the tumor-associated antigens, means the antigens that are exclusively expressed in tumor cells, but not in healthy cells. Okay. So these tumor antigens will be eaten up by the dendritic cell, and you can see the maturation of the dendritic cell, which means the tumor antigens now presented on the dendritic cell surface. Why dendritic cell? Why not the other cell types? There are several immunocompetent cells you have in your body. For example, B cells, or macrophages, or monocytes, neutrophils. There are several. Why dendritic cells? Dendritic cell, if you recall the classification of immune system, there are only 3 cells termed as professional antigen-presenting cells. And among those 3, dendritic cell stands number 1 because it is capable of triggering or activating T cell with a very, very high potency. That's the reason why dendritic cells are very, very important in terms of boosting your immune system in an antigen-specific manner in this procedure. And once these antigen loaded dendritic cells that will be infused into the same person's body. So here there is no outside cell coming in. The cells that are originated from patient, you are doing some alterations in vitro, and again you are infusing back into the same patient. So it's a kind of autologous way of treating the patient. Okay, this is nothing but a dendritic cell-based vaccine, which means what actually currently happening with several companies in India and abroad is that assume that a patient suffering from one sort of cancer. Okay, a small biopsy from that cancer will be taken. That biopsy will be chopped off into very, very small pieces. Okay, and those small pieces we fed to the dendritic cells that were originated from the same patient. Okay, which means You are taking out the biopsy from the patient as a sample, and you are also developing dendritic cells from the same patient, and you are making it to eat, which means you are training your own dendritic cells in a outside the body in vitro, and again you are reinfusing those dendritic cells into the same patient to trigger the T cells which are supposed to kill the cancer cells. Okay, it's like a kind of priming your own immune system with your own cancer burden. Okay, this is the basic classical concept of dendritic cell vaccination. Okay, can you cure the cancer? This is the next question. No, you can't cure the cancer in this procedure. It is very rare, but you can extend the lifespan of the patient. That is also okay. If not 1 year, if we could survive for 4 more years, which is good, and quality of life. Okay. Then thought came like in our previous slide, we have taken a kind of a biopsy sample and chopped off into small pieces and fed with the dendritic cell, right? Then the idea came to the scientists like, why don't we make a kind of RNA molecules? From RNA, you will have proteins, right? So those RNA molecules that are exclusively expressing the cancer-specific proteins, we technically we term as neoantigens. Neoantigens are nothing but cancer-specific antigens. Okay. So then the scientists got idea. Okay, how it would be if we can just introduce the neoantigen manufacturing RNA molecule. Okay. So the leukapheresis is nothing but blood collection from the patient only, and then you just isolate the monocyte. There are machines available nowadays. We need not have to do any manual separation or centrifugation like that. But there are specific machines available for all these tasks. And then you cultivate in vitro for a week's time in a specific growth media containing cocktail of cytokines. You can make immature DC, and then you introduce the RNA molecules for especially tumor-associated antigens. Okay, you can electroporate them, and then you can make a mature DC, and you can reinfuse into the same patient. Okay, so these are different classical concepts currently evolving to introduce the cancer-specific antigens to prime the patient's own immunocompetent cells. Okay. Okay, I mean this data is really very important to those who are actually in need. There is one company called Apex Biotech, which is located in Gurgaon. They actually got approved by CDSCO in 2017 to treat the patients like what I just explained. They are not actually electroporating the RNA. They are actually taking the biopsy sample and feeding the in vitro expansion of the dendritic cells and infusing those dendritic cells into the patient body to extend the life. Okay. So if anyone, whoever wants to have this information, you may contact them for patient treatment. They are qualified doctors. And there is one more company by the name called Dendritic, which is located in the Delhi. Okay, you have the contact numbers also displayed here. Okay, and they also have branches in several other countries as well. And these two are approved by CDSCO, but these listed 5 units they are not yet approved. Sooner or later they may approve. So now coming to the CAR T cell therapy, this is where actually we are working in pharma. What actually this therapy is that this slide illustrates the basic flowchart. Okay, first we collect the blood from a leukemia patient, okay, and then we separate the T cells from the blood, and we introduce a chimeric antigen receptor gene, generally we call it as CAR gene, into the T cell. So you can see the expression of CAR gene on the cell surface of the T cell, and make sure that your CAR gene is expressed in quality control testing by using several methods, FACS, fluorescence activated cell sorting systems, and several other things. And you grow them, these CAR T cells, into millions of cells in vitro in the lab, and check one more time the efficacy of the killing to the target antigen. And once you are happy with the quality control, you infuse these cells into the patient body. So that you can see within 2 weeks of the after infusion, you will have 90% of the malignant B cells die within 2 weeks. But of course, the treatment procedure and follow things will happen for 1 year. But the data suggests within 2 weeks, 90% cancer burden will go. Okay. So in one shot, you can cure the leukemia like this procedure. I mean, the procedure looks very simple, but there are several complicated steps involved in it. It looks very simple, but every step is really very, very critical. There are hundreds of clinical trials going on with CAR T cells. So just yesterday, I updated from the website US government clinical trials data. I noticed that around 1,200 clinical trials are happening all over the world as per the heat map shown here. Unfortunately, in India, it is falling 0 to 1 category, right? So, yeah. I don't go much into these slides. I mean, these are classical CAR constructs, how they got evolved actually, what are all the domains that are responsible. I will try to give a kind of a bird's eye view of this CAR construct. You will have one extracellular domain, which is supposed to bind with your target antigen, and you have the intracellular domains that is supposed to get activated to prime the T cell and trigger the perforin granule pathway, which you have seen in the video. Okay. With this slide, you can see what are all the target antigens actually targeted on various cancer types and the CAR construct designs. I mean, we are working, Pulse Pharma, we are working on CD19 and CD20, right? These are all various markers exploited in various cancer types. One thing I would like to mention here, in case of brain tumor, glioblastoma, it's a very, very serious problem, and I would say no effective drugs so far, other than surgical resection. Right? There is one clinical trial going on in the US, delivery of CAR T cells directly into the intracranial pump injections, because brain is the organ where it is very, very less immunosurveillant. I mean, among our body organs, nervous system per se, right? It is very, very less immunosurveillant. That's why most of the viruses, they exploit and stay like heaven in the nervous cells, because it is very difficult to recognize by immune system. And another example, the plasmodium parasite, which stays in red blood cell, erythrocytes, because There is no MSc class 1, there is no MSc class 2 expression on reticulocytes because there is no replacement, right? So these are the safe havens for pathogens to stay, right? And of course, you heard blood-brain barrier. Blood-brain barrier crossing is not so simple. It is very, very restricted. Certain amount of molecular weight molecules cannot cross the blood-brain barrier, which means, suppose you are suffering from headache. You want to take some antihistamine like paracetamol kind of thing. You need to take huge quantity. Then only you can go to the brain and it works, right? But relieving pain in the other parts of the body is very simple when compared with your headache because it cannot cross, right? So that's the reason why these guys actually trying to deliver the CAR T cells directly into the intracranial by using a small pump. So clinical trials means we don't know whether it works or not. Don't be under the impression that it will work all the time. No, that's not true. But there are kind of testing events one has to pass through, then only it will come as an approved therapy. Okay? But you should have some rationality before proposing some clinical trial. Okay? The ethical committee has to go through and accept it, whatever you are talking about, and they will suggest some amendments you have to consider with their experience. It's a kind of a long-term process. Okay. So, actually in 2017, US FDA approved two products, and of course, the European market MRs. One is by Novartis and another one is from Kite Pharma. These two products got approved in 2017, and even in the very late stages of leukemia, especially the cancer types that I highlighted in red boxes here, they can be treated by using CAR T cell therapy. Okay, so we have approved products in the world because I personally take interviews to select the candidates and the kind of quality what we are getting and what mistakes we should not do. I would like to discuss, which is very much essential for you guys. Right? I'm very sorry to tell you my experience is very bad. One guy came from, I don't want to name the university, but did his MSc in biochemistry. I just asked, just tell me a name of one biological macromolecule. That's it. He said, I don't know. Right? That is the kind of quality of the people that we are getting. I'm not saying everybody is like that. That's not my intention. The kind of tips and tricks what I wanted to give you is following. That is much more attractive for you guys. See, biology is a ocean. Dr. Shivkumar is expert in one field, mainly signaling. And I'm more of cellular immunology. I'm not a signaling guy. What I'm trying to say is that whatever topic that you choose, be master in that. That is very, very important. The first question what I asked, if any one of you candidate like you come for entry, what is your favorite topic? I'm not imposing my favorite topic on you. I'll ask you guys, what is your favorite topic? Where you are really good at it? మిమ్మల్ని అడుగుతాను మీ ఏ ఫీల్డ్లో క్వశ్చన్స్ అడగమంటారు వాళ్ళు చెప్తారు కదా దాంట్లోనే అడుగుతాను కానీ దాంట్లోనే ఆన్సర్ చెప్పాలి అదే ప్రాబ్లం నేనేమంటానంటే మీకేమో ఇంట్రెస్ట్ ఉంటాయి కదా కొంతమంది బయోకెమిస్ట్రీ తీసుకుని కొంతమంది బాటనీ తీసుకుని కొంతమందికి వేరే వేరే ఫీల్డ్స్లో ఉంటాయి దాన్ని దాటి బయట క్వశ్చన్స్ ఎవరు అడగండి, మీరు చెప్పిన దాంట్లోనే అడగండి. ప్రాబ్లం ఏంటంటే మీరు చెప్పిన దాంట్లోనే మీరు ఆన్సర్ చెప్పండి. అంటే పైన కాదు, కొంచెం డీప్గా చదవండి. దట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్. రెండవది, కొంతమంది ఇంటర్వ్యూ తీసుకునే వాళ్ళు మిమ్మల్ని కన్ఫ్యూజ్ చేయడానికి ప్రయత్నం చేస్తారు. మీరు మీకు తెలిసిన డొమైన్లోకి ఇంటర్వ్యూ చేసేవాడిని లాక్ రావాలి. ఆ ఆర్ట్ మీ దగ్గర ఉండాలి. మీరు మాట్లాడుతున్నది అతను అడిగిన దానికి రెలవెన్సీ ఉందా లేదా అని కాసేపు తీసి పక్కన పెట్టండి. అంటే ఎవరిని లాగుతున్నాడు, అతను మిమ్మల్ని లాగుతున్నాడా లేదా మీరు అతన్ని మీ డొమైన్లో లాగుతున్నాడు. ఇది చాలా ఇంపార్టెంట్. నేనేమంటానంటే మీరు చాలా స్ట్రాంగ్గా ఉన్న డొమైన్లోకి వచ్చేట్టుగా ప్రొవోకింగ్గా మీరే మాట్లాడి అతన్ని మీ గౌరవం తెచ్చుకోండి. అప్పుడు ఆటోమేటిక్గా మీకు తెలిసిన సబ్జెక్ట్ క్వశ్చన్ అడుగుతాడు, మీరు ఆన్సర్గా వాళ్ళకి సమాధానం చెప్పి క్వాలిఫై కావచ్చు. ఇవన్నీ ఇంటర్వ్యూ స్కిల్స్ అండి. ఏ పుస్తకంలో ఉందో మీరు ప్రాక్టికల్గా పడి తెలుసుకోవాల్సినటువంటి విషయాలు. ఓకే. అండ్ రిగార్డింగ్ ఇందాక డాక్టర్ శివకుమార్ గారు చెప్పినట్టుగా వీఆర్ ఆల్వేస్ రెడీ టు హెల్ప్ యూ గైస్. కాంటాక్ట్ us. At times we will not be able to reply to immediately, but certainly we will get back to you. Okay? మీకు ఏదైనా క్వశ్చన్స్ ఉంటే కనుక నన్ను అడగాలంటే యూ క్యాన్. Otherwise, you can send me later also. No issue, no problem. Yeah, no, please. Sorry.
We are reducing them and again giving back. Additionally, also the person is exposed to the tumor antigen continuously. Then even though the dose may be less, but how can this therapy?
It's a fantastic question, Devi. I have not really expected this question from you guys.
PhD in immunology.
There you are. ఆవిడ అడిగిన క్వశ్చన్ మీకు అర్థమైంది చెప్తానంటే కొంచెం మార్చి రీఇటరేట్ చేస్తాను. ఆవిడ నన్ను అడిగిన క్వశ్చన్ ఏంటంటే, ఫ్రెండ్లీగా మాట్లాడుతుంటే, అరే నువ్వు అన్ని బాగానే చెప్పావు, ఇమ్యూన్ సిస్టమ్ అందరికీ ఉంది కదా, మా అందరి ఒంట్లో ఇమ్యూన్ సిస్టమ్ పక్కకి పనిచేస్తే అసలు క్యాన్సర్ కలిగి వచ్చింది. నువ్వు చెప్తున్నావు కదా అద్భుతమైన టీసెల్ ఉంది, అదేమో చిల్ చేస్తుంది, అన్ని బాగానే ఉంటే అసలు నీకు ఫస్ట్ ఆఫ్ ఆల్ క్యాన్సర్ ఎందుకు వచ్చింది? క్వశ్చన్ నెంబర్ 2, క్యాన్సర్ ఆల్రెడీ పేషెంట్ ఉంది కదా, అంటే నువ్వు బయటికి తీసి కోర్ రిసెప్టార్స్ లైగేషన్ కూడా ఉండాలి. వాటిలో there are several things. Mainly I will talk about PD1, PDL1. ఈ PD1 అనేది మీకు నార్మల్ సెల్స్ మీద ఉంటుందంటే PDL1 అనేది క్యాన్సర్ సెల్స్ మీద. ఓకే, ఈ PDL1 ఎప్పుడైతే మీకు క్యాన్సర్ సెల్స్ మీద హై ఎక్స్ప్రెషన్ ఉందో, it mimics the T cell as if I am a normal cell. అప్పటికేంటి, T cell కి నార్మల్ సెల్ కి క్యాన్సర్ సెల్ కి తేడా తెలియదు. It will not get activated. And then it feels that it is my cell. The T cell feels that there is no abnormality in it. So it will be escaped. They choose the cancer patients లో breast cancer కావచ్చు, మిగతా cancers కావచ్చు. వాళ్ళు చేసే ఫస్ట్ బయాప్సీ టెస్ట్ ఏంటంటే ఆఫ్టర్ స్టేజ్ ఆఫ్ ది క్యాన్సర్ అండ్ అదర్ థింగ్స్ PD-L1 ఎక్స్ప్రెషన్ ఏ లెవెల్లో వస్తుంది. దట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్. PD-L1 ఎక్స్ప్రెషన్ లెవెల్స్ కనుక మీకు ఎక్కువగా ఉండి అది కనుక మీకు బ్లాక్ చేస్తుంటే ఈ కిట్రుడాల్ అనే మ్యాప్ యాంటీబాడీ కనుక మీరు వేస్తే మీరు కీమోథెరపీ తీసుకోగలరా, సెల్ థెరపీ తీసుకోగలరా, ఆటోమేటిక్గా చంపేస్తారు. దట్స్ వై ఇట్ ఈస్ $14.4 బిలియన్ స్కేల్స్. ఓకే, నేను చెప్పింది ఒక ఎగ్జాంపుల్ అండి, బట్ దేర్ ఆర్ 2 more other molecules also, right? LAG3, right? PD-L2, ఇలాంటి molecules చాలా ఉన్నాయి. But among these three, PD-L1, PD-1 blockage, దీని యాక్సిస్ బ్లాకర్స్ అంటున్నాం. PD-L1, PD-1 యాక్సిస్ బ్లాకర్స్. ఈ బ్లాకర్స్ మీద నాట్కో ఫార్మా, ఆరిజిన్, డాక్టర్ రెడ్డిస్ కూడా ఉంది, BMS, క్రిస్టల్ మేస్కి, ఇలాంటి పెద్ద పెద్ద కంపెనీస్ స్మాల్ మాలిక్యూల్ ఇన్హిబిటర్స్ని డెవలప్ చేస్తాయి ఈ యాక్సిస్ ఇన్హిబిటర్స్ కోసం. అవి కనుక మనకి మార్కెట్లో ఇంకా స్మాల్ మాలిక్యూల్స్ కావాలండి, ఓన్లీ మ్యాప్స్ వచ్చాయి టు బ్రేక్ ద యాక్సిస్. స్మాల్ మాలిక్యూల్ వస్తే మనకి అడ్వాంటేజ్ ఏంటి, వీ కెన్ టేక్ ద పిల్ డైరెక్ట్. అదే మ్యాప్ అనుకోండి మీకు ఇన్ఫెక్షన్ ఇవ్వాలి, ఓకే, బికాస్ దట్స్ ప్రోటీన్ కదా, మీరు తింటే డైజెస్ట్ అయ్యారు ప్రోటీన్ కదా. ఓకే, సో ఐ థింక్ since you are immunologist, you will be able to ask this question. Yeah, that's what I'm trying to say, sir. Whatever may be the type of cancer, after identification of the grade and the stage of the cancer, one has to test the PD-L1 expression. If it is there, it is more, then you can.
Srinivas? Hi to everybody again. So we met yesterday briefly, and we just generally talked about how to decipher the function of a gene in layman's terms yesterday to some extent. How to study the function of a gene, right? Well, be it the plant system, animal system, or whatever it is, how do we study the function of a gene, right? To understand, to come up with therapy for any disease, you have to first understand the biology behind the disease, and biology is dictated by the function, by the way the genes are regulated. Okay? In general terms, very simple terms we are talking about. No complication, nothing. If you have to develop a therapy for any disease, you have to understand the biology of the disease, and biology is controlled by the way the genes are regulated. There are several thousands of genes. We try to study the function of one gene. How do we study the function of a gene? That is important to learn. Experimentally, how can we study the function of a single gene? Okay? I will come to that. But before that, I would take you through, like we discussed yesterday, in our body there are a lot of different cell types. Many different cell types. They communicate with each other. They always talk to each other. There is a means to talk with each other for the cells. For us, there is a mic here and talking, you can listen to me, there is a communication going on. In a similar fashion, the cells communicate with each other. We learned a little bit yesterday. The macrophages communicated with the bacterial cell. In the cell, like, with the help of the surface receptors on the bacterial cell and surface proteins on the macrophages, they bind each other. A signal is given to the macrophage that you have bound to a bacterial cell, kill it. So that signal, the cell-to-cell communication is very important. When you look at the cancer tissue, and nowadays, I mean, the most important diseases that we have to deal with are, one of the most important diseases is cancer, heart disease. What are the given them what only you slap me with the data that supports what I told. You slap me with data that supports your head. అంటే కంప్యూటర్ వచ్చినప్పుడు మనం మొదటి ఎక్స్పెరిమెంట్ చేయాలి ఇది ఆ లెవెల్కి మీరు అందరూ అవి చేయదలుచుకుంటే ఆ ప్యాక్షన్ అక్కడ మీరు ఎక్సెల్ అవ్వాలి ఏదో మేము కూడా ఉన్నాము అలా ఉన్నాము అంటే దాన్ని ఆర్డినరీ లైఫ్ ఆర్డినరీ థింగ్స్ ఆర్ బోరింగ్ వెరీ extraordinary things are enthusiastic to look at. So it's up to us whether to remain ordinary or satisfied. In any field, okay. ఇది జంప్ అవుతుంది ప్లగ్ చూడండి మనకి ఏమంతండి shall we do it or what do we think quickly 12:40 but they have to go for lunch 1 o'clock is fine 40 minutes 20 minutes I don't want to show that. It's my personal photo. What is happening, man? It's not closing yet. Okay, fine. All right. So the title that I have is actually this title is an inspiration. I am not a fan of Balaya, but the title is inspired by his dialogue. Okay, I am not a fan of Balaya. The title is inspired by his dialogue. ఒకవైపు చూడు రెండో వైపు చూడొద్దు తట్టుకోలేవు. Okay. So initially I kept a title, The Two Sides of NF Kappa Signal. The two sides. I wrote a review, I published. The review title is The Two Sides of an oncogene called YY1. It has రెండు వైపులు ఉంది. ఒకవైపు చూడు రెండో వైపు చూడొద్దు తట్టుకోలేవు. అలాగే the good and bad of NF Kappa signal. It has two sides, the good side and the bad side. We don't want the bad side. We want the good side of NF Kappa signal. Okay? It sometimes watching movies helps. You get some kind of crazy ideas from the dialogue. They might be having some lunch or something in the afternoon. We were talking about some his science. If he is actually, how do I say? I am less than a atom when compared to him. I am a subatomic particle when compared to him. So you can imagine what is he. Okay. So I was just having a chat with him. And he said, he put his hand on my shoulder and said, come on, let's go walk on the lake side and Lake Geneva in Lausanne, Switzerland. So those moments are really kind of very, very happy moments in life. That such a scientist actually, he walked with me in Geneva, Lake Geneva, in Lausanne, Switzerland. But then it was not a chit-chat walk. We discussed about some potential project and he offered me a postdoctoral position in his lab. I went to his lab, but changed my entire thought process. How pathways, signaling pathways that are operated in cancer cells and normal cells in the immune system, in other heart diseases, liver diseases, so many things he did. That's why he got more than 300,000 citations. What are citations? When you publish something, others would look at your work. What's your name? Bindu, what's your name? Mallikarjuna and Bindu, you do some research here, you publish a paper. Then somewhere else I read your paper, based on your work, I get an idea and I do some other work and I cite your paper. Mallikarjuna and Bindu et al. Did so and so work at Rajamandri College. So based on this, we are developing this idea. Like that, you get cited. If nobody cites your work, means it is not interesting for anybody. If he has 600 citations, that means 600,000. Sorry, 300,000 citations means that many people got excited about his work. Can you imagine? My citations are 7,000. Where am I? So, just to introduce, my friend also introduced me to Gunther Hammerling and what's his name, Jorasan. He was also a Nobel laureate. So to kind of introduce you to this kind of people, we kept these photos. You look at the authenticity, you better listen. You look at his photo, you better listen to what I say. That kind of a quote. Right. I love him. Yeah. Yeah. What we work on, one aspect of metastatic cancers. What is metastasis? Anybody know? Cancer is cancer. What is metastasis? Anybody? Students. What is metastasis? మీరు అనుకున్నది చెప్పండి ఏమనుకుంటారు చెప్పండి ఏ ఆన్సర్ చెప్పినా పర్వాలేదు క్యాన్సర్ గ్రోత్ స్టార్ట్ టు గో ఎట్ వన్ సైడ్ అది చాలా పెరిగిపోయిన తర్వాత అక్కడ ప్లేస్ సరిపోక ప్లేస్ సరిపోక హ్యాస్ టు మూవ్ టు అనదర్ పార్ట్ బాడీ సో ఇక్కడ నుంచి అక్కడికి వెళ్ళాలంటే హ్యాస్ టు డిటాచ్ ఫ్రమ్ దిస్ సర్ఫేస్ ఒక సర్ఫేస్ మీద గ్రో అయ్యేది ఓకే అక్కడి నుంచి డిటాచ్ అయ్యి ఇంకోటి చెప్పాలి సో ఐ హావ్ టు గో ఫ్రమ్ హియర్ టు దేర్ right? Get detached from the surface. Otherwise, I can't do. Right? Likewise, the cancer cells, otherwise, any cell has to migrate from one vehicle to another vehicle. It has to first detach from that vehicle and go to a tube. Right? The other thing is, but the problem is, when any cell detaches from its surface, when it is attaching, it releases signals because of central communication. And those signals would provide survival signals. The cell will survive. Okay. When it detaches, because it has to migrate to some other side, it loses the connection with the other cell to which it is attaching. And as a consequence, the survival signals that were previously given to this cell when it was attached, surveillance signals were given. When it's detached, those surveillance signals are missing now because the connection is lost. Now there is a stress to the detached cell, right? And that stress would cause apoptosis of the detached cell before it reaches the destination. It will die. That's a process called scientific term that you don't need to remember that. Understand the concept. The scientific term for that kind of a death is called anoitis. When a cell detaches from the surface, and because of the stress, dies, that is called anoitis. Okay? So normal cells, when a liver cell should stay within the liver, you should not go to brain. Right? Doesn't make any sense that a liver cell detaches itself and goes to the brain. Does it make any sense? What's your name? I'm asking you. Huh? Sit down. Does it make any sense that the liver cell detaches from liver, goes to the brain and sits there? Makes no sense. Brain cell has to sit in the brain to do its job. Liver cell has to sit in the liver to do its job. But a cancer cell, a cancerous liver cell can go anywhere it wants. That's what is called metastasis, right? So the liver cancer cells we talk about grows here to a certain degree, and then there is not enough space available within the liver region. And again, one more thing to kind of talk about is that generally in our body, every organ is kind of told this is your boundary. You have to grow only up to that boundary. Do not go beyond. So that happens in body for us. Right? So liver has a boundary. Naturally designed boundary. You grow only up to this region. Not any surface, not any display. Some molecular things. It's all genes in the end. Okay, I'm not talking about gene regulating mechanisms there because you will get confused. not get anything. I'm talking them as much as possible. Now, similarly, when the cancer is growing in the liver, it reaches its boundary, there is no more space to grow, therefore it detaches from here and goes to some other side to migrate to some other side. And why it's there and it's not growing secondary tumor. Primary tumor and grows to some other side, lungs, whatever, on the secondary tumor. We just learned that when the cell detaches from its surface, it should die because of the stress. But the cancer, metastatic cancer, will not die. So, normal cells అయితే surface నుంచి detach అయిపోతే చచ్చిపోతుంది. చచ్చిపోవాలి. Cancer cells detach అయినా కూడా కావాలి. ఓకేనా? ఏమైనా క్వశ్చన్స్ ఉందా దీని మీద? ఎందుకంటే ఉన్నారు ఎందుకు చావు? మీరే అడగదు. ఎందుకు చావు? What is the molecular biology there? That is not there in normal cells. So cancer cells have developed molecular biology to suppress the death process, even if it is death. Right? So what is it? Okay, one of the ways that we work on how metastatic cancer cells escape the death when they detach from the primary site of tumor development. Before they reach the secondary site, there is some time it takes to go to the secondary site, lungs or bone marrow, wherever site. There is some time. During that time, the cancer cells should survive and then form a secondary tumor. What are the genes that help metastatic cancer cells from surviving when they detach? That's what we study. Okay? One of the points. And then a major development that came from my lab when I was at the University of Cincinnati, we developed a project on the NF-kappa B signaling. My boss, Michael Curry, is the founder of NF-kappa signaling. I learned a little bit from him. I execute that in my lab. We developed this project in multiple myeloma. It's a blood cancer. It grows in the bone marrow. The B cells of our immune system, which produce antibodies when there is an infection. The naive B cells, they don't produce antibodies. Naive B cells, since they are resting, when they are activated, they start producing antibodies. The antibody producing B cells are called as plasma cells. These plasma cells will go to bone marrow. You know what is a bone marrow? Do you know what is a bone marrow? Most of you? I am not a non-vegetarian, but those who are non-vegetarian should know what is a bone marrow. Right. You cut the bone, for example, cut this end and this end, there's a hole in the bone, you put the PBS and swash it out, whatever you get out is the bone marrow contents. Right? So the plasma cells will go to the bone marrow and start growing there as it forms a cancer there. That is multiple myeloma. Okay? When they become cancerous. Normally, in most of our bodies, whenever there is an infection, plasma cells are produced, long-lived plasma cells, they live for a long time, they go to bone marrow, they keep producing antibodies against the infected pathogen, but they will not become cancerous. But in some unfortunate individuals, due to mutations or whatever, myeloma happens. Okay? How do we treat any cancer? It's a major question at the end of the day. There are so many different pathways. It's not just NF-kB pathway. We have MAP kinase pathway, AKT pathway, mTOR pathway, TGF pathway, Wnt signaling. So many signaling pathways are there, and most of them are hyperactivated in many cancers. So it's not very easy to follow all the signaling pathways unless you acquire a lot of knowledge. And so in any case, the question is, how do we treat cancer? If you say that the cancer is formed because of a signaling pathway, that NF-kB is hyperactivated, uncontrollably active, and causing the proliferation of the cells, then with that information, can we develop a drug? I say that in normal plasma cells, NF-kB signaling is regulated. It's not very highly activated. It's activated to a degree it is required. fantastic outcome. If any factor that facilitates transcription of a given gene is a transcription factor for that gene. NF-kappa-B is a transcription factor. It was first identified by David Baltimore's lab. He was a Nobel Prize winner. Fantastic finding. So unfortunately, my drawback or weak point is that when I kind of get, I was supposed to talk about NF-kappa-B, and I deviated to cortisols because of this guy. He destroyed my talk. Okay. And now I came across David Baltimore. He got a Nobel Prize. Why would he get a Nobel Prize? Yeah, it's not like something that distributes to everybody, like Malaya gets. Right? I'm not a fan of Malaya, but I like him. Right? Nobel Prize is not something that you give to everybody. You have to find something that is really impactful. What David Baltimore stands for? How many DNA comes from RNA comes from DNA? That is transcription. Okay. That was long ago. When there is no idea of the central dogma of molecular science is that you get DNA, inject DNA to RNA, protein, and we follow that. Okay. That is the level of learning that we all have. Whatever is in the textbook, whatever I'm talking about is there. It's there in the literature. I'm not there. Specific antigen, particular epitope, only one people have the receptor of a particular epitope involved. Only antigen specific site to find. There will be only one T7 which can find a specific site on a bacterial antigen. The number of bacteria that come into our body are more because we are infected. There are millions of bacteria. To find out how many cells you have, only one or two cells. They are not sufficient. If I have to fight with all of you, you will kill you. Zero. Okay, you will perform the next process. I need to proliferate. I need to proliferate to produce more cells so that I can fight. That example, 42%. That is it. Likewise, there are so many bacterial cells in the body, the number of cells that can fight are very few. So they have to proliferate. The signal comes from enough commodity. PCR, if we receptor on the surface binds an antigen, immediately enough commodity is activated, you will give a proliferated signal to the T cell that will proliferate. Okay? And to a certain degree, one T cell after proliferation, that is 1,000 or 2,000, 10,000, then the same enough commodity will give a stop signal also to stop. So that is what is the controlled proliferation. Okay? The controlled proliferation is under the NF-kappa regulation. Now imagine when NF-kappa is activated, proliferation is happening, and you lose the control on the negative step. You stop now. The stop signal is gone. What will happen? Any of you decide? We talk about controlled proliferation. NF-kappa pathway is activated. It is allowing the cells to proliferate in a controlled fashion. After proliferation for some time, it gives a negative signal. Stop it now. If you lose that stop signal, what will happen? Huh? Tell them, speak out. Tell whatever you know, you have to speak out. Otherwise, I get bored. Speak out, what do you think? If you lose that negative signal, the stop proliferating now, that signal is lost, that negative control is lost. What will happen? What proliferation is what? Uncontrolled proliferation is what? You can tell them. That is the bad side of NF. What is the good side of NF-kappa-B? Controlled proliferation. If you do not have NF-kappa-B, the controlled proliferation is not there. The T cells will not proliferate, so bacteria will kill them. The good side of NF-kappa-B is that it will facilitate controlled proliferation of T cells, so that it will fight off the infection, so that we are alive because of NF-kappa-B. That is the good side of NF-kappa-B. The bad side of NF-kappa-B is when it is overactivated. Beyond the degree, beyond the level it is required for our normal healthy state, which is uncontrollably activated, that will cause uncontrolled proliferation. That is the bad side of NF-kappa-B that happens in cancer. I think that this message, if you go home with this message, largely I'm successful. Yeah. Very quickly, the NF-kappa B is a family of proteins. It's a transcription factor. It binds to DNA, causes the transcription activation of so many different genes involved in immune responses. And when NF-kB is highly uncontrollably activated, it regulates the genes that are involved in the cancer and cause proliferation of cancer. So there are 5 proteins in the NF-kB family. So the names are here, P65, LB, etc. Okay. I will not go into the details. Just go to this slide here. So normally, the NF-kB proteins, they form a heterodimer. What is a dimer? What is a dimer? 2 molecules together. That's a dimer. What is a heterodimer? P50 is an NF-kappa B family protein. I have a family where 2 brothers, whatever. So in my family, I am one another brother, sister, whatever. So like that is a family of NF-kappa. We have 5 proteins. P50 is one of the NF-kB family. P65 is another family. They form a heterodimer. And this heterodimer complex is very, very transcriptionally very active. Okay. We want the function of NF-kappa B only when there is an infection. Before that, do we want it? We don't want it. When there is an infection, there is a signal given to the cell membrane. Then this is allowed to go into the nucleus. So under resting conditions, when there is no infection, nothing, NF-kappa B is a transcription factor in the cytoplasm. A transcription factor can do its job in the nucleus or in the cytoplasm. And what is the guys? A transcription factor should be in the cytoplasm or should be in the nucleus to do its job. Nucleus. Thank you. But the cells are designed in such a way that when there is no infection, nothing, NF-kappa B was kept in the cytoplasm, which is prevented from going into the nucleus. There is another protein, an inhibitory protein, that binds to this heterodimer and keeps it in the cytoplasm. It cannot go into the nucleus. If it does not go into the nucleus, it has no function to do, no job to do. It's kept in the cytoplasm. But when there is an infection or a signal activated from the cell surface because of protein-protein interaction on the surface, a lot of regulatory mechanism happens. A kinase complex is activated that will phosphorylate the inhibitory protein, which binds to NF-kappa B and keeps it in the cytoplasm, prevents it from going into the nucleus. So the inhibitor gets phosphorylated, means a phosphate group is added. After phosphorylation, more mechanism happens. This protein gets degraded into pieces. The inhibitory protein is chopped off because of the upstream signal. When there is no inhibitor to bind to NF-kappa B and keep it in the cytoplasm, when there is no inhibitor to bind to NF-kappa B and keep it in the cytoplasm, inhibitor is gone. What will happen? Goes to nucleus, right? Because there is nobody to keep. Right now, you guys are sitting here. You are forced to sit here because I am blabbering something. Unfortunately, you are forced to sit here because of me. The moment I go from here, you will jump out. Right? Is that correct? At least one of you say that. Okay. I like that answer. It's like that. So, that's how NF-kB is regulated. But when you do this kind of negative, there are many negative regulatory steps on the activity of NF-kappa B. When you do such negative regulatory molecules on NF-kappa B, NF-kB is constantly activated. That causes cancer. Okay. So, I think perhaps we can stop it here. If you are more interested about our work, you can always come back to us. So, what I would do, we are supposed to learn how to purify plasmid today, but I will explain this when we go to the lab, how to purify plasmid. So why do we need to purify plasmid? I want to study NF-kappa B. That is saying the P65, I think that it is the cause for multiple myeloma cancer growth. Okay. To study NF-kappa P65 gene, in whether really it is causing myeloma cancer, what I want to do is I want to PCR amplify the NFKB65 gene, put that into a plasmid, and put the plasmid like he did. He amplified the CAR receptor, and he put that into a plasmid, and this recombinant plasmid having CAR, he put that inserted into the T cell. Now the T cells will express the CAR on the surface, which can bind cancer cells. Like that, you can study any gene. So you need to learn how to purify a plasmid so that you can use the plasmid to insert the gene of your interest into the plasmid and then put the recombinant plasmid into the cell type of your choice and study the function of that gene. So for that, we have to start from the scratch, from the ABCD of molecular biology. Plasmid purification, PCR amplification, gene cloning. These are all like drinking water for our lab. In our lab, my lab, we do this every day. These are ABC. These are Australian Japanese. These are Australian. Molecular biology, Australian. Plasmid interested, passionate about it, come to beyond this, you can approach me and Kishore for whatever help you want. If you want to do science, the doors are open for you. That's my contact details. If anybody wants to contact me for some help, we cannot help everybody for internship or whatever. I promise you that I will interact with you. Whomever I find are capable of getting into research and help at least 2 or 3 students. I'll force him to take 10 students. He is bigger than me in only. He has more money. Bigger than me in brain. So he take more. No, he's more intelligent than me. I have no problem actually with that. So he should take more students. Okay, see you guys. If you have any questions, you can ask me. Absolutely. So any disease, yeah, the question is, there are various ways to kind of treat cancer cells based on the molecular mechanisms that have gone wrong in a cancer cell, right? Similarly, can we also treat an autoimmune disease? Right? That's the question. It's a very good question. To begin with, you can sit down. Any disease is caused because something has gone wrong. Okay, whether it's autoimmune disease, cancer, or any inflammatory disease, any disease, is because something has gone wrong. We have to first identify what was the cause for the disease, molecular cause. Okay, and autoimmune disease, like one individual may have one autoimmune disease, systemic lupus erythematosus, somebody may have SLE, lupus, somebody may have autoimmune pancreatic islet destruction that causes diabetes, somebody may have autoimmune destruction of the eye, uveitis, is relative has got that. The uvea region inside is destroyed by the T cells and slowly you lose the sight. So there are so many different autoimmune disorders. Each disorder has a molecular mechanism. If you know if you study the details of the molecular mechanism behind all of these, you can develop it. But when it is autoimmune disorder, because whichever T cells or T cells are produced, they were fooled to recognize our own cells as foreign. What is autoimmunity? Our own immune cells are attacking our own body. Because they were fooled to detect our own cells as foreign cells. That's a pathologic system. We cannot prevent the immune cells from getting generated because we need the immune cells to fight off these cells. But while generating cells, some bad immune cells which are fooled to recognize our own cells as foreign cells, they keep destroying. So you have to kind of give immunosuppressants or specifically the mechanism that is happening in the target cell, perhaps you can release those targeted model where the receptors are binding, which is a receptor now in the cure therapy. But largely, autoimmune disorders are like cancer. Okay, I hope nobody in your family has not been. So, regarding PhD or anything, just so, if you have questions, you ask me. Otherwise, I don't know how much time we have. If you want to do PhD, do science, you have to do PhD. For PhD, is learning methodology has changed, completely changed. Okay, you should argue, basically. You should raise questions, argue, and think. So the thought process should change. Okay. And you should also know about CSIR, ICMR, DPT, so many leadership giving our body subjects. You should try to track one of them. Okay. There's a way to study for that. To do that. And if you have a fellowship, you have a PhD degree because you go to some institute if you have fellowship. If you don't have fellowship, it's a problem. In major institutes like university, etc., we want students with fellowship largely. But there are institutions, which may accept students without a fellowship also. But at least qualified gain. Some competitive exam you have to qualify. To prove that you have that capability in your mind, you do PhD. Right? You do have. Every one of you. If I have done PhD, all of you can do it. Okay. So, the reason why I'm saying is that I never thought that I would become a scientist in my life. He knows how I am. That's what I told. He used to study in the library. I used to go to movies and play cricket all the time, like that. Okay. I never thought I would become a scientist. But then, like I said yesterday, మనం ఎంత గాలి తిరిగినా సరే సారీ సార్ ఒక ప్రాక్టికల్గా మాట్లాడితే స్టూడెంట్స్ కలుస్తుంది మనం ఎంత గాలి తిరిగినా సరే ఏదో లైఫ్ మన లైఫ్లో లేదంటూ నాట్లో నేను ఏం చేయగలను నా ఐ కెన్ ప్రూవ్ ఓకే నా ఎక్కువ నేను సాటిస్ఫై చేసుకోవాలి సో దట్ మీ ప్రూవ్ దట్ మచ్ మచ్ బెటర్ దాన్ సో మెనీ పీపుల్ అనేది క్వశ్చన్ రావాలి అది వచ్చినప్పుడు యూ ఫైండ్ అవుట్ వాట్ ఈస్ గుడ్ ఫర్ యువర్ కెరీర్ యువర్ లైఫ్ ఎక్సలెంట్ ఓకే అది చేయండి CSR we end up prepare about. So when you go to research institute, you can also kind of come to us or other research institutes, approach other premier institutes, learn the methodology first, learn the thought process first, interact with people like that, and get CSR, UBC, ICMR, some fellowship, and then you can do PhD. Or you can also apply abroad, go to abroad and do PhD. Okay, our passion on knowledge first. Science scale and passion on knowledge. New just. Yeah. What do you mean by that? It's a show. But that you want to know. Hypertension will know. That was sometimes correct. No. What he is saying is that I got your question. So what he is saying that there is a tumor growing in our body, and then you design and engineer another cancer cell which will eat or kill the pre-existing cancer in our body. Both are cancers. You introduce that cancer. Once it goes into the body, it's not in your control anymore. Okay, you leave the fish in the sea. It's not in your control. You cannot control it anymore. Once it is in the body, it will start acquiring more mutations. You may have under engineered conditions, you may have a block signal for it. When you add that block signal in the engineered conditions, it may stop growing. But once you put in the body, it may acquire more mutations. It will go beyond out of your control. It may kill the other cancer. That also is doubtful. But even if you accept that idea, the introducer cancer, you don't want to do that, man. Come on, no. I think the idea is good, but that will cause more problems. What do you think? Once it's in the body, it's not in the, that's why actually, that's why actually the immunotherapy is the best method for cancer cure. Although the other example, protein is another possibility, I would still rate immunotherapy as the best method. That's why we are also working on that. Okay. We look at all of them more just. Immunotherapy is a bit costly at this moment, but it's more promising. Personalized therapy, because you take the immune cells from the patient's body itself, and you engineer them to put them into it back. Yeah, so that's why immunotherapy is the best therapy. Your idea is good, but implementation is very difficult. Yeah, please. Yeah. Yeah, that's what I think. Yeah, it's a good question. It's a good question. So you ask me confidently, it's a loud voice. Come here. Tumor antigen. Tumor antigen.
See, the question is that it is not a question of non-recognition. You recognize. Biology, we have to find what we call geology of biology. Biology, is one of the simplest value. First chapter is value. It is controlled by one single unit. Biology never rely on one single unit. First, we have to remember. Number two. If you check that here, recognition is very process of it. And the piece of research are you check India and the recognition is very కానీ ఆ ఒక్క సెగ్మెంట్ సరిపోదు. Yes, recognition of one particular cancer factor. I explained earlier, rectal factor. ఆ ఒక్క సెగ్మెంట్ సరిపోదు. దానికి ఇంకా ఫర్దర్ యాక్టివేషన్ సిగ్నల్స్ పోలీస్ రిపోర్ట్స్. యాక్చువల్గా మేడం గారు అడిగిన క్వశ్చన్ నేను అడిగిన క్వశ్చన్ ఒకటే, కానీ డిఫరెంట్ ఓరియంటేషన్ మీరు అడిగారు. యాక్చువల్గా మేడం గారు అడిగిన క్వశ్చన్ ఎప్పుడైతే అదర్ పోలీస్ రిపోర్ట్స్ సపోర్ట్ లేదు, వాటర్ ఒక రిసెప్టర్ తీసుకురా ద్వారా ఇది క్యాన్సర్ సెల్, ఇది మన సెల్ఫ్ మేడ్ ప్రోటీన్ కావాలి అని డిటెక్ట్ చేసిన ఈ సెల్ not just by recognizing the cancer identity. It means further assistance from police sectors. Ultimately, like several of technical, technical, the ultimate terminal activity is terminal activity. That's one grandson pathway. Don't make the targets on that. Okay, the corresponding grandson pathway is for awareness. Certain threshold signal కావాలి. కేవలం ఒక్క సిగ్నల్ సరిపోదు. దాన్ని ఎన్హాన్స్ గా మిగతా సిగ్నల్స్ కూడా ఎక్కువగా కావాలి. And then equalization, when a T cell reach to a kind of no point of return, yes, I have taken a decision. Now the peripheral granule pathway gets activated. And then when the picture signal started, then only you can see it. Like that. Our picture signal rather than just water signal. The cancer cells in as connected. The picture signal will 50% picture. They are good. Okay. అందుకే సమయంలో మీకు నేను చెప్పినట్టుగా ఇంక్వైరీ కూడా బయటికి ఆ మిగతా సిగ్నల్ ఇస్తున్నాయి కదా వాటి ఎనర్జీ వాట్ ఆర్ డూయింగ్ చేసి ఒక ఎనర్జీ యాంటీజెన్ స్పెసిఫిక్ టీసెల్ ఫుల్ those features also can be while dendritic cells, professional organization. What is it for? ఇలా కాకుండా ఇప్పుడు నేను చెప్పినట్టుగా అసలు ఒక ఫైనల్ యాంటీజెన్ రిసెప్టార్ దీన్ని స్టోర్ చేసి పెడితే దానికి కూడా చెప్పాల్సి అక్కడ beauty of CAR T cell is it doesn't require any other question understanding.
Sorry. Why are you question? No, the CAR T cell connection. Why did you never చెప్పారు? Target tumor antigen identify చేసి expose tumor antigen. దానికి CAR receptor పెట్టారు. డైరెక్ట్గా బయట బయట ఆ కంటెంట్
It doesn't require any question. నేను చెప్పేది చెప్పింది ఒక నార్మల్ classical T cell activation. But in case of CAR T cell, it doesn't require any question. Just binding to the target and then it is. That's why it is more powerful and more safe.
Normal scenario, tumor cells X protein, new protein, do not go down. Really speaking, because of the presence of the X protein, which is new on the surface of cancer. Our own body, right? But it's different from the normal cells because it has new X antigen. Ideally speaking, it is just circulate. Because it will get automatically, when it binds to police everything will happen to it. Normally speaking, they go there, it is on it. It is a tumor tissue. It just goes to the tumor tissue. It is a tumor tissue. It has the X antigen also. The new antigen to bind to and still it is coming. But still it does not happen. There is metabolism of the tumor. It does not happen because tumor cells secrete factors or produce some other process which will inhibit of the co-receptor signaling that co-receptor signaling is also required for the T cells to actually kill also bind to the X protein. So the critical signaling pathways that are required for the function of the T cell are inhibited by cancer. But when you put a CAR primary antigen in the T cell, it does not rely on all other activation pathways. It go to the cancer cell, bind to the X protein, kill it. That's why the hope is that the primary CAR T cell primary antigen hopefully it will be some cure. You are doing. Oh, Jesus, man. Jesus.
Any more questions? If no questions,
Respected in-house principal sir, and today's discourse persons, faculty from on-site colleges, research scholars, dear students, good afternoon everyone. Myself, Dr. Devasita, faculty in biotechnology of this college. So today's two sessions are very fruitful sessions and thought-provoking sessions because first resource person, sir, has enlightened us about the CAR T cells, how they use to kill the cancer cells. So, a new approach, a new pathway, which is applied, new, which is opened the door for cancer treatment. That's what I understood. So second resource person, even though we have some obstacle like power failure, sir try to make us to come into the track and he has highlighted the previous session about the CAR T cells and sir also enlightened us about the NMKB pathways, how the signaling pathways are very, very important in controlling the cancer cells. So I hope the participants are more benefited out of this session. So afternoon session is a technical session. So I request everyone to participate with this eager and enthusiasm. Once again, I thank the DST Stuti coordinator, sir, and convener, sir, Dr. Mallikarjuna, for giving us this wonderful opportunity to taking part in this event. Thank you, one and all. Now I request Mallikarjuna, sir, for further proceedings.
Thank you, Vasudha madam. So now it's time to felicitate our resource persons, eminent personalities. Sir, please accept our small felicitation. Sir, I request in charge of principal Vishweswara sir and all in charges, Dr. Nageshwar madam, Vasudha madam, and Srinivas sir, please come on to the desk. And Shailaja madam. No doubt, dear participants, hope you enjoyed two lectures. So one thing we have to accept, so real inspiration, sir. Even though we are in bigger positions, so your simplicity, and interaction with the students really very inspiration to all us, sir. Thank you, sir. Take the moment and show. First, I invite Dr. Kishore, sir. Come under the desk, sir. So I request the in-charge principal and other faculty, DST, the coordinator, Srinivas Prasad, sir. Students, give a big clap. Really wonderful. Ilanti session మీరు ఎక్కడ కూడా వినుండరు నాకు తెలిసి బహుశా అంత యూస్ఫుల్, highly informative and innovative and useful to your career also. So give a big clap. Even though very busy schedule, most stars are very scientists. అయినా కూడా ఎంత busy schedule. Sir, please join sir. So now I request Dr. V. Shivakumar sir, Associate Professor, Isaac Therapy. It is also one of the prestigious institute in nation. Sir, please accept our felicitation, sir. I request again all in charges and Madam sir, please felicitation. Shivakumar sir. So really great day. So participants ఇక్కడ ఎవరైతే ఉన్నారో మీరంతా రియల్లీ అదృష్టవంతులు ఈరోజు ఇలాంటి సెషన్స్ వినడం అనేది బహుశా వెరీ రేర్. Individual గా it's not possible to meet Shivakumar sir and Kishore sir, but it's the platform to meet and to clarify your doubts. Thank you so much, sir. Now it's time lunch time. So it is at Metcalf Hostel Mess. After that.